we might be on, but I'm going to go confirm on the other computer.
Sounds good.
Can you hear the cat in the background?
Oh, is that Kitty?
There was a cat. I'm curious if you can hear it.
Oh, I can kind of hear something, but not. I did not make it out to be a cat. I like how your background shows that you're also musically talented.
Is it too much? Should I pull it?
It's fine.
Does it seem like I'm showing off?
No,
I play the keyboard.
Hey, I play the keyboard too. No, I just noticed your green screen didn't take up the whole background.
Is Eric still asleep?
I think so. Well, not really. I think I woke him up.
We are definitely on now.
All right.
Until we have basically the number of viewers is sort of equal to the number of people that I know are in the gather space.
Okay.
That's kind of a test of making sure that they have actually, clicked the right button, and then we're
All right. Sure. All right. Sounds good.
I wonder if I can pull it up on my phone and just have the sound off, see if it's playing for people.
Yeah.
You can go to the Racket YouTube channel. It'll show up there.
Okay, great. Thank you.
Oh yeah. Yeah, I see you. You're on YouTube, Lindsey.
I'm on YouTube.
You're famous.
Woo, famous. Now are you noticing every detail?
It's like the green screen's supposed to make the background
Not matter.
not noticeable, but now I feel like it's like, oh, I need to watch my green screen.
Go to one of the TVs. You can go up here in the lower left-hand corner. You can put the play button there, and you can click on it. It should full screen as well. I'm also going to be pressing the quiet mode, so that other people can't talk while a presentation is on, but you can use the chat. So if we use the chat, it's basically tag you if you're having a problem.
I'm so sorry. It looks okay.
It was all bloody last night.
Was it?
Yeah, it's swollen.
Are they? I didn't notice when I got up, so I'm hoping. So early for a Saturday morning, right?
It's just like workout.
Oh, okay. It was kind of a workout. You're playing with it.
I'm not playing with my hair.
Yeah, you are.
It's just relaxing to
Yeah.
stretch like this. Just stretching.
Okay, so welcome to RacketCon, everyone. This is our second edition of the virtual version. We intend to be in person all together next year. And this year, we have a nice set of talks. If you go to the con-racketling.org, you can see a list of them. And our first talk will be by our keynote speakers, Stephen Foster and Lindsey Handley. And they introduce yourself, guys. Say hi.
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 And they have this amazing project that they're working on that's called CodeSpells. And when I first heard about what they were working on, I was just really blown away. And they've prepared a really great presentation for us. And let me just kind of walk through a little bit, though, before we get started, the parameters of how the conference goes. So if you go to the webpage, you'll see a link to the Gather space. It's called Gather Town. And that's like a virtual conference space where you can walk around. And as you walk around, you'll automatically be connected with other people at the conference that are near you. Also in the space, you'll see that there are little documents and there are little TVs around. When you go up to one of the documents, you can press X and it will open up a Google Doc where you can type in questions that you have for the speakers. And at the end of their presentation, I will deliver all those questions to them. Also, when you go up to one of the TVs, in your lower left-hand corner of your screen, a little YouTube window will appear. And you can click on that and it will fully expand. You can press play. And then the live stream will start. After every session, I'm going to be updating the URL that those TVs are at. So if you leave for one session, then come back and it's still expanded, you're going to have to close the window, and then not the Gather Town window, but you have to minimize the YouTube TV, walk away from it, and then walk back, and it'll refresh. Since Racket has many other channels, so for instance, there's the Slack channel, the Discord. I'll look in those, but if people ask questions, I will kindly ask you to add them to the single space. If you're having difficulties with Gather Town, you can message me on any of those modalities, Slack, Discord, or through Gather Town, and I can help you with the problems. Finally, all the videos of the whole presentation will be archived on YouTube for people to watch later. So with all that out of the way, let's get started with the first presentation. So how this is going to work is that I'm going to be sharing my screen, specifically the YouTube, specifically the video playing, and that'll be broadcast to YouTube for everything like that. Let me just fix something. I hear the background noise. All right. All right, you should all be seeing the first frame of the presentation. I'm going to confirm that I can see it on the YouTube. All right, good. Okay, all right. And we'll take it away. Well, hold on, I'm actually going to mute you two and turn off your video just in case.
Hi everyone, my name's Lindsey Handley and this is Stephen Foster, and welcome to our RacketCon talk. I'm going to switch into dark mode and get things started. First we wanted to Hi everyone, my name's Lindsey Handley and this is Stephen Foster, and welcome to our RacketCon talk. I'm going to switch into dark mode and get things started. First we wanted a little teaser. I am to our RacketCon talk. I'm going to switch into dark mode and get things started. First we wanted to start with a little teaser. I am about to summon a dragon. All right.
Wow.
So we've cast a spell to summon a dragon that spits fire.
That's just a little teaser, just to get you excited. But first up, who are we? So Lindsey and I founded ThoughtStem back in 2012, and our goal has been to spread computer science education throughout the world. We've done it through teaching kids in K through 12 and adults how to code, and we've also made educational technology for the last 9 years, CodeSpells being one of those. And we've co-authored a book called Don't Teach Coding Until You Read This Book. It's a book for computer science educators and students.
And who is this talk for? Well, we really wrote this talk for anyone who is interested in Racket, Unreal, or React. CodeSpells integrates all three of these runtimes. I know there are a lot of people here today who are interested in Racket, since this is RacketCon, but anyone who is also interested in the Unreal game engine or React.js would also be interested in CodeSpells. Also educators, so anyone who has wanted to show their students the magic of coding. I think CodeSpells could be an incredibly powerful tool for educators to really wow their students. And then finally, any potential collaborators. So if you are interested in writing a paper with us, if you're interested in using CodeSpells in your research or in your classroom, or if you are interested in funding this project either by hiring us as postdocs or financially supporting the project in some other way, this talk is for you.
So before we dive into CodeSpells as a technology, I want to point out that we're actually using it, right? The dragon was spawned in CodeSpells, and the slides you see on top of the 3D world, that is CodeSpells. So we're already using it. The whole talk is CodeSpells. a little bit of history, though. It hasn't always been this flexible a platform. We see a picture here on this slide of the UI for the very first version of CodeSpells. I designed this back in grad school, much younger. And you can see a little Java on the left and a little documentation on the right, and a copy button where you can copy that spell to your inventory and then use it in the world to set something on fire. This is actually part of a PhD thesis project. It actually started as an undergrad project, but I rolled it into a PhD thesis project that generated many publications back in the day. I've listed a few of them out here. I'm not going to necessarily go over them, but if you want to do further research, here are some titles and authors. And I want to do a big shout out to two people. One is Sarah Esper. She was my lab mate back in grad school, and a lot of the publications about CodeSpells and a lot of scientific research was pioneered by her. And William Griswold, who was our advisor. So without those two people, the first version of CodeSpells just wouldn't have existed, and neither would the version that we are presenting in today.
We were really excited about the research about CodeSpells and just the concept in general, and we felt like we could make CodeSpells into a really amazing AAA game, but we weren't a big studio. We're not a big game studio, so we ended up launching a Kickstarter for the CodeSpells game and receiving a lot of support from thousands of parents, educators, gamers. And we released a game on Steam in 2015 with the help of Adrian Lopez Mobilia and Jason Rosenstock. Adrian was our lead programmer and Jason Rosenstock was our environment artist, and they brought so much magic into the game. You can see here how beautiful the game was. It still is. You can get it on Steam today. And as you can see, users could craft their spells using this Blockly editor and then cast their magic in a beautiful 3D world. So we released this game back in 2015, and once the Kickstarter funding ran out, it kind of sat there for a little bit until more recently.
Yes, and that's when we decided we wanted to pivot back to this project. It's been a passion project for us for years now, over a decade. And we wanted to do it in the technologies we really are passionate about, and so there are three of them actually: Racket, React, and Unreal. These three runtimes we think have a lot of potential in and of themselves, but when you combine them together, you get something really special. We wanted to show with CodeSpells. We also wanted to make it more of a platform than a game, more of a way to make games, for example. And we definitely wanted to pivot back to our original focus, which was education. So you'll see that this is a tool that could be used by educators to present to classes or to make educational technology, and also a technology that you can give to students, and then they can make games in it. So we wanted it to be sort of all of these things. And I think by the end of this talk, you'll see how we're definitely moving in the direction to even be able to use it in that way today.
So as we discussed, CodeSpells has its roots in research. We think the new CodeSpells platform has a lot of value that it can provide to researchers still. So we wanted to talk about some of the related work where we think that CodeSpells could be useful. The first area of research is visual syntax, the mixing of code and UI. There were two recent publications that jumped out to us, one from PLDI 2021, this Livelets paper from Cyrus Omar's lab. The next one is from OOPSLA 2020 from Matthias's lab, this adding interactive visual syntax to textual code. And we believe that the CodeSpells platform can be used to prototype novel coding interfaces like these because we're using the rich React ecosystem.
Another area of research, a large one, is multi-agent systems and simulations. There have been results in this area since 1971. Schelling's work on segregation models, which you can find digested in a fun way in Parable of the Polygons if you Google it. The Sugarscape result was an interesting result as well. In simulations like Sugarscape, you code a bunch of very simple behaviors for a bunch of very simple agents, and you as a researcher generally are looking at emergent properties of the system as these agents interact with each other. NetLogo is a programming environment for making these kinds of simulations, and we think that CodeSpells, with its 3D world and the power of the Unreal game engine behind it, can be used for making other sorts of interesting simulations, ones that involve 3D space and ones that involve a robust physics engine, which of course comes out of the box with Unreal.
Another area of research where we think CodeSpells could be a benefit is games research, specifically gamification in education and serious games. CodeSpells makes a lot of aspects of video games very accessible to prototyping video games that researchers might want to prototype. And then CodeSpells is also just a VR-capable platform, so any VR-based interfaces that anyone might want to research could be implementable in CodeSpells.
And of course, our roots as CS educators and CS education researchers make CodeSpells a platform that we believe can be used to answer some of the open questions that remain in this field. Prior CodeSpells research showed that the metaphor of magic itself is an effective way to build curriculum and to teach coding to kids, especially in middle school. Also, the Racket community's How to Design Programs philosophy teaches coding in the context of increasingly complex programming languages, beginning with the beginner student language. And interesting open question might be, are what kinds of beginning student languages or what kinds of teaching languages can be created in the context of having a 3D programming environment like Unreal? Also, there's much debate about whether text-based coding or block-based coding, visual coding, is sort of best for novices. And I'm not going to weigh in on that debate today, but let me just suggest that there's an open question, which is what about the underexplored middle ground between the two, that where you kind of combine both text-based and block-based coding into some richer programming environment that you study. So we think there are lots of open questions in CS education research, and that CodeSpells is the perfect platform for asking and answering many of these questions.
All right, so for our first trick, we wanted to show off some basic Racket evaluation. So here you see some code that probably looks very familiar. We're doing some addition, we're doing some string appending, and then some Boolean logic. And if I cast the spell, we get back some output that we expect. We've added 4 and 5, we've appended hello world, and we have false. So let's think about what's happening behind the curtain. So this is a React component. It is a Racket editor. And this React component sends its Racket code over to a Racket server, and that Racket server evaluates the code and sends the output back to the React component so that it can be rendered here inside the React UI. But let's do a more complex example.
So this one actually has an error in it intentionally. I think it won't take your eyes very long to find it. It's pretty early in the code. But obviously it wouldn't be good if Racket only ran code that works. Having error messages and line numbers is important too. So if we run this one, we'll see that Racket handles the error and passes it back to the React component in a way that you might expect. It says error on line 3, division by 0. So we can delete that, obviously. And the rest of this is just a demo of the fact that you have the full Racket language at your disposal in these editors. So there's some composing of stuff. It's a little too fancy, obviously, for a Fibonacci, but we did it on purpose just as a demo. Also, yes, it's not the most efficient Fibonacci algorithm, but whatever, that's not the point of this talk right now. So if we run it, then we'll see some Fibonacci numbers come up. And just once again showing that you have Racket at your disposal inside of the UI here.
But we have this whole 3D world behind us, so let's use it. So here we have some Racket code that will build a sphere of size radius 1000. But as you can see, we have built a sphere, a voxel sphere in the world, and you can see it right here. So let's think about what's happening. So this React UI component is sending this Racket code over to the Racket server. Racket is responding to React with void because this is a function that just has a side effect in the world and doesn't actually return anything. And then Racket also sends the evaluated code over to Unreal, and Unreal actually turns that into a sphere in the world.
And if we look at these next few examples, you'll probably notice that our API here is similar to, and definitely inspired by, 2HTTP image or Pict or Pict 3D. And you can see that sphere 1000 here doesn't actually have any side effects. It just allows us to store into the variable s the idea of a sphere, which we can then build later. And in this case, we're building an s above an s. So if we do that, then we'll see a sphere above a sphere. We're actually inside of one of those spheres right now, but we can exit and see what we might expect there. Notice it merges into the sphere that Lindsey made earlier because the voxel engine actually kind of blends these shapes together.
Yep, and we have made the necessary changes now that we're in 3D space. Beside is now beside wide or beside deep. So in this example bit of code, we have two spheres that are beside each other and another one that's above. So we should get a triangle. And if I enter the world, yep, you can see our little triangular formation of spheres. And if I change this to beside deep, it should be going in the other, along the other axis. All right.
Yeah, definitely. Voxels are very performant, so we can actually make these kinds of structures. In fact, we can make much bigger structures than the ones we just made. So let's do that. This next code is a little bit of a puzzle. We didn't want you to know what it would do right away, but maybe some of you will figure it out. I'll let you look at it for a moment. The sphere is in the variable s, and then the triangle function looks familiar, or should look familiar. Lindsey just ran something similar to that earlier. The foo function is the obfuscated function here, but at the end of the day on line 15, we're building a foo3s. So let's see what a foo3s looks like here. See, yeah, it's building. What is it? Ah,
Oh.
look at that. It's a Sierpinski's triangle. And that's actually not very big. I think we can do bigger. Let's go
Can
bigger.
we go bigger? Let's go bigger.
Yeah, let's do a foo5s.
It's foo5s.
These fractals get big fast, so let's not be too ambitious.
Oh,
but I think a foo5s.
it's coming.
Oh yeah, yep, exactly. Nice.
Whoa.
Fairly large, reaching all the way down into the valley down there. Yeah, there we go. So we can watch it build. All right.
So right now, the only primitive shape we have implemented is spheres. We're definitely interested in implementing more of the primitive shapes that you'd expect, but we're also interested in more complicated builders. So we've made a small API for building rooms. So rooms, of course, would be like a layer for like the ceiling and the floor and the walls. So if we cast this spell, it should build a room that's 2000 by 1000 by 600. And if we enter, hopefully I didn't stop it. Oh, yep, I stopped it. Well, we have these little buttons here so that if you have an infinite loop or a long-running spell, you can stop your spell. You can either stop this spell or stop any spell that's running. And let me enter the world and move a little bit. And then let's try building this room one more time. There we go. So as you can see, it's building the ceiling and the floor, and it's going to go and build all the walls. And right now it's just using spheres, but we'll have other primitives in the future that can make different kinds of rooms.
There's a lot more to come, but first a quick commercial break. Did you notice that these slides are like the coolest PowerPoint you've ever seen? They're like Jupyter notebooks with a 3D world integrated with them. Wouldn't you like your slides to be as cool as these? Wouldn't you like to use these for your classes? I think you would. CodeSpells.
CodeSpells. So all of our examples so far have us casting a spell using this cast button. Sometimes, of course, though, you want spells to run depending on events that are happening in the 3D world or in the game that you're playing. So in this example, we're going to use projectiles. First, we have to clear all of the projectile hit functions that we may have subscribed in the past. But essentially what this function does is subscribes a function that builds a room at the projectile hit's location to on projectile hit. So every time a projectile hits in the 3D world, this build room function is going to get triggered. So if I cast the spell, nothing's going to happen right away. But when I enter the world, I can launch a projectile using just a click of my mouse. And as you can see, a room starts building around that location. It's a little bit embedded in the ground because it's centered on where the projectile hit. So if we wanted to lift that room above the ground, we could just do a little bit of vector math to add a vec onto here. And that vec is just going to be in the z direction, and we're just going to do 300 since that's half the height of the room. So if I cast the spell again, it will clear the last projectile hit function that we subscribed, and it's going to subscribe this new function. And now when I do a projectile hit, yeah, it's building the room a little bit higher off the ground than it was before. So let's think about what's happening behind the scenes. So our React component here with the Racket code in it is sending the Racket code over to the Racket server. The Racket server is not evaluating this code right away. It's actually storing the code for use later. So it's registering the function to on projectile hit events. And then it is responding to Racket with just this void output right here. But then when we're later in Unreal and we are actually shooting projectiles, Unreal will send a message to the Racket server to say, hey, I just fired a projectile, or a projectile hit event just happened, and the Racket server is going to respond with this function that we subscribed before.
And those Racket functions actually, they're legitimate Racket functions, so they can close over variables. So here in this case, we have the variable size, which starts at 100, and we're doing it on projectile hit, and that lambda closes over size, and the first thing it does in the lambda is adds 100 to size, and then if it gets too big, if it gets above 1,000, it sets it back to 100. And then at the end of the day, it builds an air sphere at wherever the projectile landed. So it'll be an air sphere no matter what, but it might be a small one, it might be slightly larger until it gets too big, and then it'll go back down. So there'll be different sized craters that we can create in the world. We can destroy something we've previously made, perhaps.
Oh.
Always fun. Oh, interesting. Oh, we didn't run it. Did we run it?
Oh, no. Forgot to run it. Always run. Always cast your spells, folks.
Always run.
All right.
Yeah, there we go. Yeah, so destroying things always
Woo-hoo.
fun. Ooh. Wow, you popped yourself. Yeah. Spells shoot you out of the way.
Yeah.
It's for fun. No particular reason other than that it's fun. Yeah, eating into those voxels there.
So we talked about projectiles. Another kind of event you might want to happen is some sort of trigger zone. It's a common thing in games where you enter a certain zone and then something happens. So let's see the same concept but with a different kind of event. So once again, we're clearing any functions we had subscribed recently, and we are creating a new on projectile hit function here. We're subscribing a new one to spawn a trigger zone, and we're going to name that zone trap. So this zone is going to get created wherever our projectile hits, and then whenever we enter that zone, we're subscribing a function such that when the zone has the name trap, we're going to build a room there. So this should do something similar, but our projectile hit is going to create the zone, and then when we enter the zone, it's going to create the room. So if I cast this spell, and enter the world. Now let me just do it on top of this other room. We will see our zone. So our zone is this like little magical circle right now. And when I enter that zone, it starts building a room around us. It's a trap.
A trap.
Let me run out real quick.
Yeah, run out.
Ah!
Run out.
Okay.
If we get too trapped, we can't finish the talk.
Yeah. All right.
So that brings us to our next commercial break. If you think CodeSpells is looking kind of like a game engine, well, you're not wrong. We want CodeSpells to be a platform for people to make games and simulations and interactive experiences. So if those are things you like, then CodeSpells might be the platform for you.
So sometimes you don't want to write all of your code by hand. Sometimes it's just easier if you have a little widget to do all of that work for you. So here we have a room UI widget that helps us lay out the rooms of a house or a palace or whatever we want, really. And we can place rooms and we can place doors. And as you can see, it's compiling out the code for us below. So every time I add a new component to the room UI, it recompiles our S expressions for us and does all of the vector math and the annoying stuff that is sometimes a little difficult to do by hand. So if I cast this spell, it's going to start building this small house for us, and we can watch that go in the background as Stephen continues with the next part.
So that's like I would say that kind of UI there is like a domain-specific UI. It makes rooms and doors, and that's pretty much all it does. But you can use the same idea of UI compiling to S expressions to implement something like a Blockly compiler. So here's a particular one that has just a few blocks in it that compile out to the same API we've been seeing. We got build, and we can build a sphere, and we can set that sphere's radius with a number block, all fairly straightforward stuff. And just pointing out that it's really the same thing. It's just UI that produces S expressions. Turns out to be a very powerful idea, and we're going to see it in a few different iterations here. But just Blockly is kind of an obvious one that we decided that we wanted to support, because we want you to be able to make a DSL in Racket, but then also, if you want to, release a Blockly interface for it, or some kind of interesting domain-specific UI for it, if you so desire.
I think I accidentally hit a button to cancel. I accidentally hit one of these stop this spell buttons, so this stopped building. But I think everyone, I think everyone gets how it works. So what if you wanted to add new Blockly blocks, or what if you wanted to, take the code that is getting compiled out from the room UI and pipe it into some other function? Well, this is where this little React editor comes in handy. So this React editor is different. You can probably notice it's a little visually different than this Racket, what we call a code mirror. It's a little bit different than the code mirror. We are just calling this the React editor, and in the React editor you can do anything that you'd expect to be able to do in React. So you can do p tags and typography and all of that fun stuff. But you could also essentially write any of these components that we've seen so far. So if we wanted to do a magic mirror, we could change this p tag to be a magic mirror. And we can set the code in the magic mirror to be whatever we want. And so we can start creating these components, or we can start composing these components together into new components. And any of these components, if you are interested in how to use them, you can check out the docs. So you can click through and learn about how events work. Maybe you can't quite remember how on projectile hit works. Oh, right, it takes a function. Oh, right, it returns void. Here's some examples. You can actually cast any of these spell examples and actually use them in the world. So I think this is going to be a really helpful tool for users. And since we're talking about user interfaces right now, we also have documentation for the user interfaces. So if you wanted to add new Blockly blocks, there will be examples that show you how to add new Blockly blocks in these little React editors.
So here's an example of us taking two of those components that you might find in the user interface docs and tying them together to make a small, interesting compiler here. So the two components are one, Conway's Game of Life component, and two, code mirror or a magic mirror, as we call it. And all we're doing is just like a few lines of JavaScript, and it will take the state of one of those components and compile out as expressions into the other. So let's try it and see what we get, just for fun. All right, yeah, sure. How about that? So let's, or yeah, we could advance the simulation to whatever state we want, doing Conway's Game of Life, and whenever we're ready, let's just cast the spell. We'll make all sorts of crazy things. Oh yeah, there it is. Fun. All right.
And this is another example of us combining different React components together to make some interesting new thing. So this is a Room UI widget, and we have two magic mirrors. So we're going to take the output from our Room UI widget, and we're going to pipe it into this magic mirror. And in the end, we're going to get some final code. So I think what we want to do with this is create an on-projectile hit event that is going to take essentially the function that's produced from Room UI. So if I put together a very small little Room UI situation. All right, we got a room or two, and we got some doors. All right, so we have our output here, and we are going to pipe this into an on projectile hit. And we want to build this every time there is an on projectile hit, and the sneaky way we're going to do this is with this whole function, which we've defined. It's pretty much just an identity function, so it takes whatever's up here and we're going to put it in this hole. And so in the bottom you can see we've put everything from the top magic mirror into our hole. And then finally we need to make sure that we are building it at the hit event location. Ooh, all caps. All right. So now if I cast the spell, nothing's going to happen right away, but once we have a projectile that hits something, we are going to see a room start building. So, all right. And cast it. Yep. And we're starting to build that little house that we designed up above.
So, commercial break. Can you imagine the cool next generation programming interfaces that we could make with the power of React and Racket at our fingertips? Come help us make them, or write us into your next grant. So we're going to go kind of fast through this slide, but this is an example of how you can use many of the UI components that already come with CodeSpells to create your own educational technologies. So let's actually scroll down to what it produces. So it produces this little panel that says, let's learn about functions, and has an embedded video. You can scrub through it, or you can run it. Videos do run inside of CodeSpells. And afterwards, there's a multiple choice question, presumably to make sure you understood the video. And if you get the answer right, which Lindsey did, then you go to the next page where more educational content, perhaps another video pops up. And in this case, afterwards, we have an editor, a code editor that a student might use. So we wanted to make sure that not only can CodeSpells be used to deliver educational content, kind of like we're doing here in this talk, but also to deliver educational technology that itself does some of the teaching for you, for students.
And we really got a lot of these ideas when we were writing our book, Don't Teach Coding. We realized how powerful it could be if we could interleave our coding examples with prose. Unfortunately, that's not possible with a book, but we are doing it now inside of CodeSpells. So calling all curriculum developers, can you imagine your curriculum being this cool?
I sure can.
Me too.
So this is a puzzle. We're actually going to skip it in this talk. It's kind of a teaser. It's going to blow your mind. So it's just to encourage you to, if you're watching this video or watching us at RacketCon, try to get a hold of the slides for this talk. You'll have in your hands a version of CodeSpells with this, with everything you're seeing right now, and you can navigate to this slide and get your mind blown if you want.
So in this example, we have an event logger component that does exactly what you would expect it to do. When I go into this Unreal world and shoot some projectiles down, it is going to essentially log each of those events. And you can see we have the raw data from each of the projectile hit events, which is essentially just an XYZ location. So what's happening here? When I fire a projectile in Unreal, Unreal forwards that event data over to the Racket server, which forwards the data over to the React component. And every time the React component gets new data, it updates the state and re-renders the data for us. So here's a similar example, but this time around, instead of just rendering out the raw data, we are going to change the component prop on our event logger so that it creates a cast button for each of the events that comes to it. So in here, we are going to build a sphere at the event's location. And as you can see, I already have the 3 events that we saw in our previous event logger up here. We have down here, but this time they are cast buttons. So if I click these, then we are going to see a sphere of size 250 render. Yep. And we have 3 spheres in the world, exactly where we hit those projectiles. So this is kind of a full circle example. So we already kind of talked about how Unreal sends the event data back to React, or sorry,
Racket.
sends the event data back to Racket and then on to React. But in this situation, we have these cast buttons, which are in the React UI, and these cast buttons are sending the Racket code over to the Racket server and then on to Unreal.
If we wanted to, we could actually expand that last example and change that cast button into a magic mirror, just to show you like that there's some pretty interesting interactions you can have with the system if you start composing all of these things we're talking about together. So now instead of cast buttons, we have magic mirrors, which have code in them, which means you can now not just run something hard-coded, but you can start massaging it, messing with it. So let's just try, let's try spawning a dragon or something like that instead of building a sphere. Yeah, because why not?
Yes.
Yeah, there's a dragon instead of a sphere. Yeah, and of course you could, if you wanted to, you could mess with those coordinates if you want it to be a little bit higher or lower, and so on. But yeah, so we're trying to illustrate is that with this system, you get interesting interactions where you're first doing something in UI, and then you're doing something in the world, and then you're doing something in code that causes something to happen in the world, which might change something in the UI, and so on. You have sort of this whole rich loop available to you. So to build on that idea of this rich loop, let's use a few things we've seen before and kind of build out interesting interaction. So first, let's make a palace with a library and a study. Just 2 rooms. We make the library maybe a little bigger than the study, and obviously we need front door, and then we'll need a door from the study to the library. And well, let's just build that. Let's start with. Let's just like build something in the world. All right. Yep. So then I believe that is our study building there, and our library will no doubt follow. But when it is finished, we'll place some trigger zones inside of it at very specific places, and some of the trigger zones will let us know that we're in the study, and the others will let us know that we're in the library. And then once that's done, we'll make it so that the React UI is aware of which room we're in, and we can do interesting things to show you something different depending on the location you are inside of this structure. I think we're almost done. Let's actually, while we're still waiting, let's clear the projectile hit events on the first line.
Good idea.
And yep. So that is the one for the library. I suppose you could just fly in there while it's building if you can get in.
That's a good
fast
idea.
enough. Yeah, all right. So then the doors should be following once the walls are all built. There's our door, beautiful. So now, yeah, we can throw down that spell. Right, so that's the zone that'll let us know once we've entered the threshold of the library. And now we'll do a similar thing with the study. So we'll go, there's actually 2 entrances into the study, so we'll cast that one twice. So we'll know if we pass the threshold from either direction. And now let's go through. So right now, yeah, so here we have this event logger down here that's logging out just the last event only. And right now it doesn't say anything because we haven't triggered one of these zones. But let's do it. Let's all right, yep, so we just touched the one that's at the edge of the study, and we are in the study, so now it says study. And then if we go back in the world and go all the way through that door into the library, we should trigger the other one. Might be a little too low down, but maybe we got it. I don't know. Yeah, there it is. Okay, cool. Yeah, so now it knows we're in the library. Now, obviously, it would be even more accurate if we had bigger zones. We haven't added bigger zones yet. We just have these small zones, but you can kind of imagine how it would work with differently shaped zones. So let's make it just, I'm picking this arbitrarily, but let's make it so that it renders, the UI renders documentation when you're in the library. Does that make sense? And then in your study is where you might want to craft spells and write code. So yeah, so if we're in the library, then we're going to render out doc modal with a button, which is the name of our component for rendering a button that opens the docs, which, yes, is in the docs as well. If you want to know how to make a button that opens docs, it's in the docs. And if we're in the study, we'll do a magic mirror. And we could just leave it blank. It'll have no code in it, and that's fine. Yeah, so here we are in the library. So now we see that we have a docs button. We could click it and open the docs if we wanted to. And then if we want to write some code, we can go into the world and hopefully we trigger that on the way. Mm-hmm. And yep, there we are inside the study, and we're able to write some Racket code.
All right, quick commercial break. So this was a pretty simple idea of a mind palace, but you can imagine much more complicated examples where you're placing your curriculum throughout a 3D world. And I honestly think that's like the coolest thing in the world. But if you also think that is really cool, then I think CodeSpells is the tool for you.
So we've come full circle now. We're going to spawn a dragon. We're going to leave our little mind palace there and find a nice secluded spot to spawn a dragon. This one looks perfect. And you notice from the code that it's going to spit fire for 4 seconds. We've built a small DSL for dragons. And here we go. We're gonna, yep, there it is, spitting fire. And if we wanted to, this kind of thing composes with all the other stuff we've seen so far. So if we wanted to, let's delete the sleep and wrap, we'll wrap Spitfire into an on projectile hit. And what this is going to do is basically when this Lambda function executes, we're going to ignore the event data because I don't really care about it for this particular example. We're just going to have the dragon Spitfire. So basically when we're going to spawn a dragon, that whenever projectiles land, it spits fire. Let's try that. All right, let's pop the wall with a projectile and see if we get... yeah, there you go. And he spits fire. He doesn't like it when your projectiles land. So this is just a call, an invitation. If you're a developer, if you want to contribute to computer science education, grab something cool off the Unreal Marketplace. There's a lot of awesome looking free stuff, and build a neat DSL around it. I mean, a dragon spawning DSL, I think people learning to code would like it. I know I would have as a kid. I like it as an adult, in fact. This particular dragon DSL, where we'd like to add new things to it, like make the dragon follow you, add some like AI primitives and stuff to let you script how that dragon behaves in the world. there's a lot of room in the world for domain-specific languages that control dragons. That's just my opinion.
We've reached the end of our talk, and we just wanted to say that if you are interested in collaborating, helping with funding, or using CodeSpells in your classroom, please reach out to us. We would love to talk to you. Our email addresses are up here. You can email us any time of day, or if you happen to be on your computer or on your phone between Monday and Friday, 9:30 a.m. to 12 p.m. Pacific time, we develop live on Twitch all of those days. So if you are interested in chatting with us live, you can find us right here on Twitch. You can also find more information about the CodeSpells project on the CodeSpells website. And thank you all so much for joining us today.
I'm clapping for the entire audience. That was pretty awesome. I'm just gonna get Stephen and Lindsay to turn their videos back on.
Oh, it says that I can't turn my video back on.
Yeah, I know. I did that. All right,
Awesome.
It should be possible for you to turn it on now.
Thank you.
Well, I mean, there are some pretty cool comments and questions, but I mean, I just gotta say, like, I just think that is the coolest thing. Like, you know, the first version that you guys showed at the very beginning, you know, where you talked about the environmental artists, you know, buildings and stuff, like, definitely that's pretty, but it's not as cool as this, you know what I mean? And the cool things that you've made are pretty incredible. I'm gonna pull up on my the questions that we've got so far. Just to make sure everyone knows, you can ask questions by putting them in the document that, you know, is at all of the document stations in the Gather, or if you put them in the chat,
Did we lose Jay?
I think we lost Jay. Let's wait a second. Maybe Jay will come back.
Which I think we're still live, which is kind of
I
puzzling.
think we are too.
Hello, RacketCon.
Hello, everyone. Unfortunately, I don't have access to the questions that Jay's talking about. Have you pulled them up or?
No, I have no idea what they are. I'm also puzzled how we can be live and not Jay.
Oh, Jay.
Oh, maybe Jay's back
great.
now.
I
Yeah,
think
that's
she's
really
back.
weird. Sorry about that.
It's okay.
No problem.
Yeah. So, okay, so I'm back. Yeah, and that's crazy that it was still live the whole time, but like I got disconnected somehow.
Yeah.
That's pretty amazing. Okay, sorry about that. I think I might have accidentally like jiggled my cord or something like that. I like got a special streaming laptop set up for this. I wonder if maybe all right, sorry. Okay, so here are some questions that we've got. So the first one is, people have a few sort of like practically minded questions, like what OSs do you support right now? Do you support like the new M1 Max? Like, what is the current like distribution thing for CodeSpells?
Yeah, this is a tricky thing for us, is like supporting lots of platforms. So I'll say in theory, we could support Windows, Mac, and Linux, because Unreal builds for Windows, Mac, and Linux. But in order for us to do that, we have to have like a machine that we can do Unreal development on, that use those OSs. And right now, our dev machines are Windows machines. So the build that's out there on our website right now is Windows. But obviously, Mac is like our kind of next thing that we want to like put into our build pipeline and start releasing builds for. And then in principle, there's no reason we couldn't do it for Linux, obviously. You know.
So maybe as like a call to action sort of thing, would this be something where if there's someone out there who says, I find this a really cool idea, I want to, you know, be the person that clicks the build button on my Mac. Are you interested in that?
Yeah, for sure. That would be a way to I think at low effort, definitely help out the CodeSpells project.
Cool. Now, what's the open source, collaboration side of this? Like, is this open source already? Do you want it to be? What's kind of that story?
Yeah, this is currently open source. You can find all of the repos on our website right now on GitHub. And yeah, so theoretically, people can start picking through the code. I think there are some proprietary Unreal things, right, Stephen? There's like I forget exactly what it is, but
Like the
theoretically,
voxel, like the voxel world in that particular build, like we purchased it off the Unreal Marketplace, so we can't just start distributing it. However, everything required to make like an Unreal project kind of function in the same ecosystem, that we described in that talk is open source. So we could sort of, like in theory, we could make a slightly less cool looking Unreal build that we could distribute to anyone who's interested. Just make it like a fully open source thing. But I would say 99% of everything is open source right now.
Yeah. And so maybe to test my knowledge of Unreal just a little bit. So essentially what you're saying is that me as like a contributor who wanted to get involved in this, I can get involved and add anything I want to, like the Racket side. I could make new kinds of code types, spell types, etc. I can do all of that, but to actually click the button and say build it and get, for example, the cool dragon model that you have, that means that like someone on your team who's already bought this thing has to be the one who has that in their Unreal. So kind of like the right way to think about this is that the main infrastructure is there, but to actually build production builds that have all of the assets as part of them, that's something that right now, costs money, but you guys are doing that and then distributing the executable that comes out for free to everybody. So it's not like you have to pay to get CodeSpells. It's just like there's kind of this development hassle there.
Exactly. That's exactly right.
All right, cool. Okay, now have you put this in front of students and beginners and other people yet?
No, we haven't. Definitely not. In fact, I predict my hypothesis would be we put this in front of a beginner and they have no idea what to do. Because like the UI right now, we've made it to be like, if you go to the website now and download what we call the clean build, the only UI you get is a code editor. My cat just jumped down and pulled my headphones out. Cat problems. What was I saying? Yes, you get the clean build and all it has is a React code editor. Like it doesn't even have a Racket code editor. So you have to type like Lindsey did in this talk, magic mirror, and then you get, you start typing Racket code. And if you know how to get to the docs, then you can open that up. But it's very much we're doing this weird kind of bottom up UI. Like we're not deciding what the top level UI is going to look like. We're trying to give you like functional primitives for creating your own UI. And I'm sure at some point we'll come up with some standard thing that ships as the default. But yeah, so it's not, no design work has been put into trying to make this friendly for beginner coders. However, if you are, let's say, like a novice coding instructor, someone with some coding skills, who's interested in like teaching with it, like using it as a teaching tool, like that kind of beginner, I think CodeSpells is ready for that sort of use. But not like a kid who's never coded before,
Yeah, so you are not there yet, and you're comfortable not being there yet because you're still building the infrastructure.
Yes. Yeah. Exactly.
Now, another kind of question is that like in your demo, everything was like live and immediately did something. You know what I mean? It's like I made the dragon and then like it's starting to, blast fireballs that's destroying the stuff that I did. I anticipate what the answer to this, but like, is there undo yet? And like, how are you going to deal with that?
There's not undo yet. But I think it's not crazy to like, just record the side effects, record anything you've spawned in the world basically. And then I'm sure you could at least destroy them, but there's, I don't know. I'm sure there's some deep physics thing going on here. Cause if you like, if you create something that like topples other stuff around and explodes something else, like you can't undo that. I mean, you can unspawn the thing that started it all, but the mess has been made, and entropy has happened. Time's arrow has moved forward. You can't necessarily go backwards. You can maybe, I mean, you have to do something much fancier to try to go backwards in time, kind of in a more general way.
Yeah, totally. Cool. Now, like, I mean, I feel like Racket's a great choice for this, but like, why is this using Racket rather than just like using JavaScript or something like that? I mean, you talked about this a little bit with your prototype, but like, what is the value that Racket's providing right now, and where do you see it providing more value in the future?
Well, I mean, there's a lot of answers to that question. I mean, one answer is just if we didn't use Racket, then the natural thing to build on top of would be JavaScript, and we didn't want to do that. It's just a not JavaScript, but like there's like a non-trivial system going on underneath the hood, because you can have many long-running spells. Like, Lindsey did it a couple times in the talk. Like she run one spell and it was continuing to build while we're writing another one and running that one and stuff like that. So there's like a system, like a little operating system underneath, and I just didn't want to build that in JavaScript. And Racket's got great like just system building primitives. It's just a good language for building systems, and so this is sort of our preference for that as system implementers. But another big reason is just straight up Lisp syntax, and because it's such an easy compilation target. Like I mean, Lindsey had like some examples where she it was like JavaScript code that was compiling out Racket code, and it's just like trivial stuff. Like it's very easy to write these things that they are compilers, but they're just so super simple. And so we get to use Racket to iterate on the semantics, and stuff, and syntax of some, set of domain-specific languages. And then we always have at our disposal the ability to write UI on top of it relatively trivially.
Cool. Now, kind of another question is, right now, well, so you talked about how you did this Kickstarter in the past for the first version of CodeSpells, and that gave you a lot of resources to do some stuff. Like, if you had all the money, like, what is the thing that you're going to do with that? Like, and maybe tell me, like, what are the top 3 things? Like, is it that right now we go off and, make really amazing models? Or is it that, like, I don't know, like right now, all of those things are spheres? My guess is that how to make rectangles. Like everyone knows how to make rectangles, but you can experiment just fine with circles. And so that's what you're doing. So like where are the holes that are back that, because like there are holes in what you're doing that are like design. You don't know what it's even supposed to do. And then there are other holes that are like engineering effort. And then there's like, other than engineering effort, there's also like asset creation. It's like, where are your bottlenecks right now? And what would you do if you didn't have those bottlenecks?
Yeah, I guess that is actually a good question. I don't know, Lindsey, what are your thoughts on top of your head?
I mean, off the top of my head, I was just thinking about how a lot of our design right now is Stephen and I on a daily basis trying to use the CodeSpell software to build something educational. So we've made a Nexus game. So if you go to nexus.codespells.org, there's a little game that starts in the web browser in React and moves into this 3D world. It uses some of the videos that you saw in the RacketCon talk. So a lot of our early development direction was, directed by trying to build that particular game. More recently, we're trying to build educational content for YouTube and different things like that. And so, I mean, at the moment, a lot of the direction is just based on us trying to, create educational content with this. And so I imagine if we had more resources, we would be able to, either continue doing that kind of indefinitely or hire people to help us build out that content. And Jay's right, like we would be able to fill in the gaps to add more voxel primitives or, I think right now that Dragon API was super duper basic, where it just spits fire. But like that Dragon in Unreal can do all sorts of things. It can fly around. It can like attack enemies. It can do all sorts of things. So building out APIs that people would be interested in using in their classrooms, I think, is something that we'd be really interested in.
Yeah, like we're kind of we're both the sole platform developers, and we're also the sole platform users. And I think that is that's it. We can do it, like, but it leaves those holes because we end up building stuff that's just for us. We're trying very hard to make it a general platform. But so to circle back to your question, if we had all the money, I think that step one would be to try to recruit like early adopter users of the platform, because that's the main thing. Is like it's really hard, to develop something when you're the only users. So I would want other people who have like a small population of people who are interested in using it in education, and then we would specifically craft platform development for use cases that kind of benefit everyone in that group somehow.
That's cool. Now, I want to pitch for you guys a little bit that I know that on your website, you have these really cool, development diaries about some of the ideas that have gone into CodeSpells. And I know that you like these live streams that you've done in the past, there's lots of really cool content there. And I highly recommend the RacketCon audience going and checking those things out. Lindsey, do you want to just say a little bit more about what people will find when they go to your website? What kinds of things are there?
Absolutely. One of the things that I definitely wanted to mention before the end of this talk was that if you go to codespells.org on the homepage, you can find the build that we used for this RacketCon talk, and it has all of the slides in there. You can click through, you can edit the code, you can cast the spells. So I would definitely recommend checking that out if you're interested in the project. And then, like Stephen mentioned, there's the clean build, and the clean build is just a basic React editor, and you can build from there. So those two builds are available for everyone. There's also that prototype game that I mentioned, Nexus. That is an hour of code right now that's available for teachers. This hour of code that's coming up in December. So all of those are available on the website. I believe there are also links to all of our social media. So if you want to, maybe you don't necessarily use Twitch, but if you wanted to follow us on Facebook or on Twitter or any of the other social medias, we'd love to have you follow development. And besides that, Stephen and I are trying to create Twitch and YouTube content on a regular basis. So come and check out the videos that we're making. We're always documenting what we're doing on a day-to-day basis. So we'd love to have more people engaged in the project.
All right, awesome. Well, thank you so much, Stephen and Lindsey.
Thanks,
We'll now switch over to the hallway section of RacketCon. And so let me just explain a little bit of how this is going to work. So in the gather space, there are 4 regions. They're labeled A, B, C, and D. And Stephen and Lindsey are going to go over to region A. I believe it's in the upper left-hand corner of the space for, to answer questions there. And we will reconvene on the live stream at 12:30, which is in about an hour and 15 minutes, when we'll have 2 talks, one from Hazel Levine and one from Sid Casavagula. And we'll continue from there. The live stream will go completely off during this time. And as I mentioned, I will update the TV screens to point to the next live stream. So you won't be able to see this, but this will be immediately archived on YouTube. And I'll see you all in the gather space. Thanks again, Lindsey and Stephen.
Thanks.
Thank you.